ActiveGrounder, which is a model designed for more reliable 3D visual grounding in unexplored environment. 3D visual grounding refers to the task of interpreting natural language queries and linking them to specific objects within a 3D scene. However, existing 3D visual grounding remains passive because it does not integrate with exploration. Most methods rely on pre-built maps and therefore fail to adapt in unexplored environments. On the other hand, image-based approaches operate without maps, but they are constrained to 2D representations and cannot generate actions, leading to an over-reliance on passive, single-image perception. Our goal is to enable embodied agents to actively perceive and ground visual queries in 3D environments. To this end, we propose ActiveGrounder, a framework that integrates active perception with 3D visual grounding, enabling robust grounding even in unexplored environments. Given a human instruction like find the bedside table farthest from the window, the robot begins searching for the target object. When related objects are detected, ActiveGrounder observes them in greater detail through object-hull-guided observation. In this way, the robot obtains images from multiple viewpoints, which provides plenty of information. We then select the best viewpoint images by considering how many relevant objects they contain and how clearly each object can be seen. Finally, the selected images are fed into large vision language models to answer the human instruction. It can ground specific objects in an unexplored environment more reliably compared with the previous passive visual grounding methods. We conducted experiments in simulation environment. The baseline method, which is a visual grounding without active perception, immediately makes a prediction with a few viewpoint images. This allows for a faster completion time, but it shows poor accuracy. In contrast, ActiveGrounder actively observes the object's surroundings before answering. Although this requires more time, it results in a much higher success rate. This comparison demonstrates how ActiveGrounder achieves more reliable grounding in unexplored environments. To conclude, we introduce ActiveGrounder, shifting grounding from a passive recognition task to an active exploration paradigm that tightly integrates grounding and action. We leverage a scene graph to maintain 3D object representations. The agent actively navigates around object hulls to observe them and selects optimal viewpoints for visual grounding. We empirically validate our framework on simulation environment, demonstrating robustness to perception errors, and an effective visual grounding compared with existing passive methods. Thank you for watching. For more details and in-depth results, please check out our homepage. If you have any questions, feel free to reach out to us.